So in coding, in programming, we have something called methods, which we've been using a method this entire time. I just didn't like explicitly say what exactly it was. But when we create our main, that is a method, all right? And we'll talk about like the format of methods, how they look, why the main looks the way it looks, so on and so forth. I apologize. Something jumped up in my throat, so if I start coughing, that's what happened. All right. So a method is just a collection of statements that are grouped together to perform a specific operation. And they have a block. They have an opening and closing bracket. So if I go back to assignment 7, our main is a method, right? It has an opening and closing bracket. It has a format to it. It has something called parameters, which we'll talk about. But this is a method. All right, so for example, and again, it's to organize your code and put behavior that's pretty similar to one another or to perform a specific operation into an organized section. That allows you to reuse it. It allows you to organize your code. A lot of different reasons for methods. So for example, you may define a method to do the following. Maybe you want a method that computes the average of a couple of different numbers. That's all it does. It just computes the average of some numbers. Or you want a method to convert user input into your program. So for example, we have a program where we're playing rock, paper, scissors. Well, we want our method to take a 0, convert that to a rock. We want a method that takes a 1, converts that 1 into a paper so that we can play our rock, paper, scissors game. Or you might create a method that converts USD or the dollar to yuans, right? Whatever it may be. So again, what we've been using, and I just haven't told you exactly what it is the main method. It's a method, just like any other method. However, to Java, the main method is unique because it's the beginning and the start of your program. Anytime you run a program, anytime you start a program, it always looks for the main, and those are the first pieces of code that it runs. All right, so this was just a visual representation of that. So we run our program from the command line. What it does is it sends a signal to the Java virtual machine, which is something we talked about at like the first or so couple lectures. The Java virtual machine is a virtual machine that sits on top of your computer, and it runs all your Java programs. And then the Java virtual machine then finds your main method to run your program. So all of your code that you want your program to start from, and it starts from top to bottom, you put it in your main. So why do we use methods? Again, the main method has a lot of different code and is confusing. So we can separate our code into specific operations. Compute the average, convert user input, convert dollars. We can add that to a separate method so we can make our main method a little bit more cleaner and a little bit more concise. We also may want to group certain code together based on what the objective is. Like I was saying, compute the average or convert USD to yuans. Another reason is if we plan to reuse that code. So in our program, we might convert dollars to yuans at one place, and then we want to do that again in another separate location. Well, from what we currently know, we would have to write all of the same code over and over again, copy and paste it. Well, with a method, we can just write that code once, then call our method, right, in different places. So every method has a signature, right? That signature is basically the format of a method, right? Our main, for example, has public static void main, parentheses, string args. Every method will follow a similar format. You may have to add or subtract different words in here, different keywords, for whatever your purpose is. The method name must be unique to that method, all right? or the method signature must be unique, or you'll get an error. So if I try to put two mains in my program, I'll get an error, all right? A method signature is a combination of the name, which right here is the main, and formal parameters. Formal parameters are what you see inside these parentheses. So if we break this down even further, the first word is a Java keyword, and it's I can't think of the type it is, but it's either going to be public, private, or protected. All right, the visibility. There we go. It's either going to be public, private, or protected. We'll talk about that further, but basically that's what you have first. And here we go, public, private, and protected. So a public method, it can be accessed anywhere in your program, right? So as we go deeper into programming, we have classes, right, and files. Well, we can have multiple files that encompass one big program. Well, in all those different files, we can access a public method anywhere, all right? A private method, on the other hand, can only be accessed within the current class that we're in. So for example, we have the assignment 7 class. If I make a private method inside my assignment 7 class, I can only use it inside my assignment 7 class. So if I create a method down here and I say private method, whatever, this method can only be called inside the brackets that encompass my assignment 7. If I try to create another file and then another class in that file and try to access this method, it won't work. I'll get an error. And trust me, we'll be doing methods a lot, so hopefully these concepts will lock in a little bit further. Protected, we won't really use too much in programming 1 or 2, but they can be used or accessed by other classes in the same directory or folder, right? Or other subclasses. That's the main difference. And make sure I stay on time, all right? Let's go to the next one. For our main method, we use the static keyword. However, for a lot of methods, those are optional. Okay, the static is optional in a lot of methods. But for our main method, we use static. Static just signals to the compiler, to Java, that there is one and only one main method. Before your program even runs, the main method gets stored in memory. It has its own place in memory before your program even runs, and it stays there for the entire lifespan of your program. It's static. It stays there and it lives forever until your program ends. Most methods don't need that keyword. The main, on the other hand, needs it. All right, so why do we have that static keyword? Mainly used for memory management. Again, it stays in memory and it's there for the entire duration of your program. It gets dedicated in memory when the whole entire class starts. It's actually when the program starts. The main method requires the static keyword because it begins the program. It's the only one in the whole program. It needs to be static. And any method called from the main requires the static keyword as well. And we'll talk about that further as we start getting into some code. The static keyword itself can be applied to several different things. It can be applied to variables, method, blocks of code, or nested classes. Blocks and nested classes we haven't talked about, and we probably won't talk about in this class, but it can be applied to those as well. You can have a static variable, and just like a static method, that static variable gets stored in memory at the beginning of your program, right? And that variable can be accessed throughout your program, and it will stay the same value. All right, here's an example of a method without that static keyword, right? The static keyword is not used in this method. Public void max, and we pass in a list of numbers. Basically, I just want to get the biggest number in this list, but it doesn't have that static keyword. All right, you don't necessarily need it in every method. All right, let's keep going. The next keyword is your return type. So your return type is whatever your method is returning. So if I call your method, right, I return, if I go back, public void max, and actually this should be something else, but void means you're not returning anything. But if I have a list of numbers, right, I would return the biggest number. So my return type would be an integer or a double. Sometimes it's a string or other different types of variables, data types. The main method doesn't return anything, so we use void. Here are some return data types. Basically, whatever you want your method to return. When I call your method, if I wanted to compute the average, obviously I wanted to return the average. If I wanted to convert dollars to yuans, I wanted to return whatever that yuan amount is. So the data types that you can return are ints, doubles, floats, lists, strings, etc. You know, whatever you can declare a variable as is what you can return from a method. So we have integers, we have doubles, we have strings, we have lists. Eventually we have arrays. All of those different things we can return from a method. So in this example, this method returns an integer, the max number. Right? So we pass in a list of numbers, we find whatever the biggest number is, and we return that from our method. All right? So that's the return type, an integer. The next keyword, and this will be the last thing I'll cover today, the next keyword or the next word is the name of your method. So our main method is called main, right? That's the name of our method. That's the last one before the parentheses, is whatever you want to name your method. Just like we name variables, we can name methods. So the method name is important. Why? It identifies your method and it's unique. It's used to call your method, and it makes your program easier to understand. So if I have a method called compute average, or if I have a method that the purpose of this method is to compute the average, I would name it compute average. That makes sense, right? That way, if somebody comes on afterwards and tries to determine what my program is doing, they see a method called compute average, well, they can assume it's computing the average of something. They may not know what it's doing, but hey, I see compute average, so it's probably going to compute average. Or if I name my method convert yuans, all right, I don't really know what this whole program is doing, but this method probably converts some yuans. All right, now we're getting into naming your things correctly, right? Naming is very important in programming, even with variables. You always want to lowercase the first word, then uppercase all subsequent words. So compute average, the first word is lowercase, all subsequent words are uppercase. All right. I will start taking off for improper naming. So if you capitalize this first word and all of the rest of them, I will take off. If you have this whole thing lowercase, I won't take off a whole lot, but I will take off for it. All right, and that goes for your variables as well. All right. So we're talking about method signatures and methods. So if you remember, methods are really good for organizing our code. Methods is one that we've been using throughout the entire duration of this course. I just hadn't identified them as methods. The main method is one that we've been using this entire time. So we talked about, this is the visibility modifier right here, public, private, or protected. Static is a keyword necessary for the main method. Void is the return type. And main is the next word that we're going to talk about, which is the name of our method. The main method is named main. Obviously, that's what we use. And so every method needs a name, just like variables. And those methods follow a similar format as the variables as well, and how you name them. So lowercase the first word, uppercase each subsequent word. So if I look at JGrasp, this is our main from assignment 7, right? We have our main, this is our method. If I wanted to create another method, your method must go outside of your main, right? Outside the main, so here's the main block, but inside of our class. You cannot have it outside of the class. It must be inside the class. So here, if I want to create another method, public static, let's say it's a void, it doesn't return anything, print, lowercase the first word, capitalize all subsequent words, print all, right? So I lowercase print, capitalize all. That is the common naming convention for not just methods, but variables as well. You always want to lowercase the first word, capitalize each subsequent word after that. All right. And if you look at our main, there's some more things here. So you see a parentheses right here, and then some stuff inside here. That's what we'll talk about next. So if we continue, the next thing right here inside of these parentheses are our formal parameters, all right, or arguments, either word. Formal parameters are what is passed to our method when we call it, all right? This is what we pass to our method. They're called formal parameters because when we pass something, those are called our actual parameters. All right. So let's talk about formal parameters. The formal parameters, with the formal parameters, you must specify what type of data is being passed. So for our main, we're passing a string, and this means that it's an array. We'll talk about arrays later. Methods can have 0 or many parameters depending on your needs as the programmer. So whatever your needs are, you can have 0 or no parameters, or you can have 15 parameters. It all depends on what your needs are as the programmer. Right? So the main, for example, has one parameter, one formal parameter, this string array, and it's called args. Right? And so again, the main method has one single parameter. Right? Only one formal parameter. However, this one, so if we want to compare two integers, int A, int B, this method obviously has two formal parameters, right? And we can do however many we want. All right, so let's create this method in our code. So public static void, I want to return an integer. And so basically this integer will say compare to int A and int B. So again, this method right here, it's a public method. Static, I put the static keyword in here so that I can call it from the main method. And actually, let me do this in a brand new class. File, new Java. So public class lecture, I think this is 13. So that's my class. Of course, we'll have a public static void main string args. And I'm just going to leave my main empty for right now. There's nothing in my main. But I'm going to create my second method, public static. It returns an integer compare to. The formal parameters are int A and int B. All right. So I create a second method. Again, be mindful, this method must go outside of your main, but inside your class here. So inside your class block, but outside of your main block, right? Because they're two separate methods. Your main is a method. Anytime you want to create another method, it must go outside of your main. All right. So for this method, let's say if A is greater than B, return a -1. If B is greater, return a 1. If they equal each other, return a 0. This method is really good for comparing and sorting. Actually, instead of greater than, if A is less than B, return -1. If B is greater than A, if B is less than A, return a 1. I just changed that up because when you're sorting things, you want the first number to go first if it's less than. So if A is less than B, return -1. If B is less than A, return a 1. And then if they equal each other, return a 0. All right, so let's do that. So if A is less than B, we want to return, keyword, -1. And we'll talk about returns more in a few minutes. Else if B is less than A, so the opposite, return a 1. The only other option is that they equal each other, so else return a 0. So again, if A is less than B, I want to return a -1. If B is less than A, return a 1. And if they equal each other, return 0. And if you remember, if we look back at our method signature, we have our visibility modifier, static, our return type. My return type is integer, so I'm returning integers, -1, 1, and 0. So that return type is important. Your formal parameters are important as well because that is what you'll be using in your method. And we'll talk about scope in a little bit. But those are available and accessible in your method when you want to call it. All right, so let's keep that there for a few minutes or for a few seconds. I'll let you see that for a few seconds and then I'll keep going. Any questions about that? All right. All right. So now you also have something called your actual parameters. Your actual parameters are the values that you pass into your method. Right? Your formal parameters will take the value of those actual parameters. So if we look at the previous slide, right, we had this compare to method we just implemented in our program. So the parameters you use when calling a method are your actual parameters. So if we look at our method, it has two formal parameters, int A and int B. When we pass in our actual parameters, int A, int B will take the values of those parameters. All right, so let's say we have this. We have int number 1 and int number 2. Number 1 equals 4, number 2 equals 15. So we call our method by saying compare to the name of our method, and then we pass in our actual parameters, number 1, number 2. And then let me do this in the visualizer so you can see what I'm talking about. So we have our main, lecture 13. Let's create our compare to method, public, static, int is our return, compare to. We have two formal parameters, int A and int B. If A is less than B, return -1. Else if B is less than A, return 1. Else return 0. All right, and then we got to close our method. So we have our compare to. Let's create two numbers. Int number 1 equals 4. Int number 2 equals 15. All right. So when we call our compare to method, it's going to pass in number 1 as A, number 2 is 15. And it's going to return either a -1, a 1, or a 0, depending on those values. So int comparison equals, we call our method compare to, we pass in our actual parameters, number 1, number 2, right? Number 1 and number 2 are in our main. We pass those to our compare to method, right? Number 1, number 2, those are our actual parameters. Inside of our method, A and B would assume those same values. We pass those values to our method, and then we return either -1, 1, or 0, depending on this comparison. So let's visualize this. So the first line is we create our variables. We create number 1. Number 1 equals 4. And if you see up here, it's saying it's in our main method. Then number 2, we created that equals 15. Okay, all inside of our main method. Well, right here, we're calling our compare to method. So what you'll see is our execution will jump down here. And the value of A and the value of B will equal number 1 and number 2, 4 and 15. See? And if you look over here, now we're in our compare to method. Our main method is down here. We have number 1 and number 2. However, in our compare to method, we have A and B. Let's see that again. So we have our main method. We have number 1 and number 2. If we go forward 1, we jump down to our compare to method over here, and we have A and B. A and B, we pass the values of number 1 and number 2 to A and B. Everybody clear on that? We do pass by value. Java is pass by value. We pass the values of number 1 and number 2 to our method down here in A and in B, 4 and 15. So then we do our comparison. If A is less than B, A is indeed less than B. We want to return -1. And you see right here on our compare to method, our return value is -1. Our execution jumps back to our main. We set comparison equal to that, -1, and our program ends. And if you see here, our program ends and the return value of our main is void. So when it was saying return value void this whole time, we were actually working with methods. You just didn't know it at that point. But our main method is a method, just like our compare to method over here. Everybody clear on that? So we have our formal parameters right here and our actual parameters up here. Does that make sense? Do I need to go through it again?
Which one are the formal and which one are the actual again?
So the formal are the ones that we declare in our method signature. The actual are the ones that we pass to the method. So we're calling the method here in our program, right? We go to our main first. We're calling our method and passing number 1 and number 2.
So the formal and what is the other one again?
Actual.
Actual. So the actual is the one at the top, like the most basic one, right?
It's whatever the values are that we pass to our method. So number 1 and number 2 in this example. But again, I can call this again in comparison 2 equals compare to, and I can pass in any values, 52, 103. Now this time we call compare to, our actual parameters are 52 and 103. Right. Let me switch these. Let's do 503. So if we visualize this again, now I'm calling my compare to method twice. The first time I'm passing in number 1 and number 2, 4 and 15. It's going to do its business, return a -1. So comparison will equal -1. The next time we're passing in a 503 and 103. So you see here, compared to A and B now equal 503 and 103. All right, so the next time we call compare to, the values change based on what our actual parameters are. So again, we're here on this line. We want to compare 503 to 103. So when we call our compare to method, our formal parameters A and B take on those values, 503, 103. And be mindful of the order in which you pass your actual parameters, because when you get to your formal parameters, it follows that same order. So for example, I passed 503 first. That means A, our first formal parameter, will take that value. I passed 103 second. That means our second formal parameter will take on that value. B, 503, 103. It does its logic. B is less than A. It's going to return a 1. Go back up to comparison 2 equals 1. And then we return void. All right. That's your introduction to methods. So we did this, we call a method by using a method name and adding the actual parameters. So if you look here, we use the method name and we passed in the actual parameters. All right, that's how you call a method. And if you notice, again, if you go back to why we use a method, one, it organizes our code really well. All right, we have a method down here called compare to. So if I go on and I look at your code and I see a method called compare to, I'm going to assume it's comparing something, right? Just based on the name alone. Plus, it allows us to reuse this code without retyping it. So previously, before we knew how to do a method, we would have to do this each time. We would have to copy and paste all this code each time. And we would have to set in compare to equals 0, or in compare to. And then we'd have to do all of our compare to equals comparison to equals -1 based on all of our logic. Now that we know we can use methods, we can just call our method multiple times. We don't have to retype all of that code. And so you see, my main is much cleaner and much more organized. So that's the purpose of using a method versus not using methods. You can clean up your main and make it more organized. So this is just another example. I already did this in the visualizer. So we kind of went over this already. But our actual parameters are number 1 and number 2 when we call our compare to method. The formal parameters are the parameters that are in our method signature. So again, if we go back up here, these are our actual parameters, same right here and right here, and these are our formal parameters. Make sense? And we can make any method we want. So we could do public, static, void, print string. This print string method, I just want to print a string. So string value. Inside this method, I just want to say system.out.println value. Cool. So let's say after I get my comparison, I want to print that comparison out. So let's do print string comparison. I print that comparison. Then do it again, print string comparison 2. I want to print that second comparison. So when I visualize this code, it doesn't like that I'm passing in an integer, so I'm just making that integer a string by concatenating in empty string values right here. So if I visualize this code, if I go all the way through, we do our comparison again, 4 and 15, comparison equals -1. We call our print string method, goes down to print string, and it prints that string right here. The return value of our print string method is void, so it doesn't return anything. Goes back up here, does comparison 2, returns a 1. We call our print string method, prints out a 1 down here, and then the return value is void. Our main method return value is void as well, and then our program ends. All right. All right. Does that make sense? So I'm just going to leave the code here for a second so you can look it over. Let me put in some comments. Created 2 variables here called the compare to method with number 1 and number 2. Called the print string method with the return value of comparison. Then I did the same thing down here, except I passed in a 503 and 103. And then I did the same thing again down here, except I passed in comparison 2.
Why did you add in those quotes after, or inside the parentheses after comparison again? Like, why did you add in those quotes again?
Right here
Yeah,
and right here.
yeah.
Because this method is expecting a string. However, the return value of compare to is an integer. So when I put this integer right here, it doesn't like that it's not a string.
Okay.
Basically,
So
I just added an empty string to it, which converts it to a string.
Yeah, okay, gotcha. This is what this week's lab is on? Like, this is what we're doing in this
I
lab?
believe
Okay.
so. Yeah.
Yeah, I think I just have to do it and then I'll be good. That's fine.
Mm-hmm. Yeah.
And that print method, is that just more, is it easier to do it like that than rather just print out, system that out, that print comparison, right? So you
Well,
can just have a method.
It depends on your requirements. So for my program, for example, I know I'm printing out the comparison, right? So I could do a print string. Let's say like the value, I have to do some other calculations. Like I want to add in, string standard output equals, I don't know, the comparison of 2 numbers is, and then I want to, oh, I don't need that. And then I want to print out standard output plus value, right? I pass in a value and then I have the standard output. Well, if I wanted to do this up here, I would have to system.out.println the comparison of 2 numbers is.
You have to do it every time, right?
Plus, yeah, I'd have to keep redoing it over and over again. Whereas with a method, I could just call the method passing in comparison. And if I wanted to make this even more streamlined, I would make this an integer, and I can get rid of this. So now when I call these methods, it's even simpler. And I call it, and I'm just going to run all the way to the end. And now it prints out all of that stuff, but I only have to call the method, you know, this simple amount of code. I don't have to keep repeating code over and over again. So that's the beauty of a method. Again, I can call methods over and over and over again, and it organizes my code and allows me to recall that method. It makes that method and the code inside of it reusable. Right? I can call compare to over and over again. I can call print string over and over again instead of having to retype all of that code over and over and over and over again. So it's really helpful for methods like compare to, when you have logic that doesn't really change, but the values that you are checking do. So the values of A and B change, but the logic doesn't change. You don't want to have to repeat that code over and over again in your main method. It makes your main method look really disjointed and really long. So you put it into a separate method, and you just call that method with the values, A and B. It cleans up your code. Questions, comments, or concerns? All right. For lab on Friday, I do encourage you all to look at the lab before you get to class, right? And try to do it before class as well, because as you've seen in previous weeks, the labs can be pretty time consuming, and I only have an hour with you all. Of course, I'll stay later if need be, but I do encourage you to check out the lab before Friday and try to do it before Friday. All right, any questions on this?